Bismillahirrahmanirrahim. Let's look at this problem. The beam is subjected to a distributed load with a maximum value of 2 kilonewton per meter. So the W here is 2 kilonewton per meter, along with the 1.5 kilonewton. So there is a point load with an angle here. Theta is 25 degrees. From the vertical axis, given the length L1, 1.25, so L1 is 1.25, L2 is 1.2, find the magnitude of the y component of the resultant force. You want to find out the resultant force in the y-axis. Find the magnitude due to all loads on the beam and its location x measured from the support A. So from this support A. Let's first of all try to analyze the loads and try to find out the equivalent force. So let's look at a different color here. So we are talking about now this one, this triangle. Okay. If you want to find out the equivalent force of this triangle, again, it's 1/2 times the value load 2 kilonewton per meter times the distance from here to here is 1.25. 1.25 meters. So meter with meter, and you'll end up with 2 with 2. So you'll end up with 1.25 kilonewton. So the first load, so let's put that in blue. The first load is 1.25 kilonewton. Okay, what is the distance now between this load, the 1.25 kilonewton equivalent load, and point A, because we need later on to find out the distance of everything from point A, and find in the moment. So the load is 1/3. So what is 1/3 of 1.25? So this distance, it is the distance of the first load. This is, let's just call this one F1. X1 from point A, is equal 1/3 1.25. So let's find out. (1.25) over 3, and that is 0.4167 meter. So this is 1/3 of 1.25, and this is the distance. This is the distance x1. Now, let's find the other triangle. So let's just erase this. Okay, let's find the other triangle. We just make it green again. The other triangle. Let's find this force. And let's call this one force 2. It is 1/2. The load is 2, same thing, 2 kilonewton per meter. And the distance here is from here to here, which is 0.6 and 1.2. So it's 1.8. 1.8 meter. So meter cancel with meter, you'll end up with, and this is with this, 1.8 kilonewton. So if you want to draw it, it's going to be, well, I need to find out the location now because point A is very close. Let's see. So it's 1/3, you can see from here to here, 1/3 0.6 and 1.2, 1.8. So that's going to be 0.6. That's going to be exactly here. at the hinge. So it's going to be here at the hinge, and that's going to be 0.6 from here, because 1.1 over 3, 1.8, that's going to be 0.6. So this is going to be 0.6. That's going to be exactly at point A. Okay, and that value is 1.8 kilonewton. Now, let's find out the vertical force here. That's 1.5 cosine 25. Let's look at cosine 25. 25 cosine 0.906 times 1.5. 1.3595 kilonewton. So now let's add up all these forces, because the first things he need to find out the FRY. So you could put it like this: FRY, and I'm assuming that this is positive. It's equal 1.3595 in kilonewton plus 1.25 plus 1.8. 1.3595 plus 1.25 plus 1.8, and that's going to be 4.409, and that is kilonewton. And of course the direction is plus, so it's going to be going down. So you're going to put here 4 point, even though this is the series significant figures, 4.409 is 4.41. Okay, so now we want to find out, this is, of course, this is correct, but let's look at the second one, finding x. We want to find out the resultant. We have this resultant, so the beam is going to be like this. This is A, and this is B. We need to find out the location of that resultant. Okay, we know that the resultant force is 4.409, and we need to find it from the support A, which means that you have to find moment from A. Summation moment at A. Let's make it in red this time. You could notice that this force is at the point, at point A. So therefore, this force has no moment, because it doesn't have a perpendicular distance from point A. So now we'll do it like this: summation of moment of the resultant of all the forces from point A. And I'm going to assume, of course, let's assume this is plus equal to. Now, let's do the first force, 1.25. 1.25 times, what's the distance between point A? You can see from here to here, this is 0.6. Let's see. No, this is 0.4. From here to here, it's 0.416. And from here to here, it is 0.6. So the distance between this force and the point A, it is 0.4167 plus 0.6. That's the moment of the first force. Now let's find the moment of this force. Remember, the horizontal forces will not have any moment because they are at the line of the action of that point A. Plus 1.3595 times. Now, the distance, it's 1.2. It's 1.25, and again, and 0.6. So 1.25, 1.2, and 0.6. You add them together, 5, 4. So it is 3.05. Okay, so this is 3.05. So now we're going to find out the moment. .05 times 1.3595 plus so this is 4.146 plus 0.4167 plus 0.6 times 1.25, and that is 1.271, and this would give you a moment of that's 5.42, and that is kilonewton 5.42 kilonewton meter, and that's we could find the distance now. Remember, the moment is equal force times the distance. We need to find out this distance from point A. So we have the moment the force times the distance. So the distance is equal to 5.42 divided by 4.409, and that would give you 1.22. 1.229. 1.23 if you want to do it 3 significant figures. So this is in meters, and that is the distance, and that's going to be, just put it here, 1.23. And that is it for this problem.